Label the model as a fraction inside the box. So here we see that 1 whole equals 1 over 1. If each square equals 1 whole, we have 1, 2, 3, 4, 5 wholes. This means that we could write it as a fraction 5 over 1. You only need one piece to create a whole, and then we have 5 pieces, each representing a whole. Number 2 says partition the wholes into thirds. Rename the fraction for 3 wholes. Use the number line and words to explain your answer. Then label the whole number fractions. To preface, I will not be writing here. I will just be using my voice to explain my work, but the expectation is that you have been writing in your own words how you would explain the work that we will do on the number line. So we need to first partition or split the wholes into thirds. I didn't mean to cross that out, but underline it. Nonetheless, I know what I need to do. And so I've created 3 equal parts between each of my wholes. And I'm going to go back in and label the whole numbers because here is 1 and there's 2 wholes that happen between 0 and 3 wholes. And now I'm going to label the whole number fraction. So I know at 0 I have 0 thirds, and to have 1 whole I have 3 thirds. And I could count 3, 4, 5. I have 6 thirds, and I have 2 wholes. It's another way to represent that. And then 7, 8, 9. 9, whoops. My hand got ahead of my brain. And 9 thirds. There. Again, as I've mentioned in previous videos, when we think about whole numbers as fractions, we can always double check our thinking and our understanding by thinking about the multiples of our denominator. So 3 times 1 is 3. If I have all 3 pieces, I have 1 whole. 3 times 2 is 6. If I have 2 groups of 3 equally sized pieces, I will have 6 pieces, and 3 times 3 is 9. If I have 3 groups of 3 equally sized pieces, I'll have 9. And something to that effect would be written here on these lines or in this space is what I was going to say before. And so that could be something like I labeled the whole numbers as fractions after splitting the number line into 3 equal parts. I know that the numerator will be a multiple of 3. Down to lesson 26. Irene has 2 yards of fabric. Draw a number line to represent the total length of Irene's fabric, and then cut her fabric into pieces 1/5 yard in length. Partition the number line to show her cuts. So ultimately she has 2 yards of fabric. She might have started with 0, and that means she has at least 1 yard in there somewhere. And so now she cuts her fabric into 1/5. So I'm going to cut her fabric into 1/5 yard pieces. So I'm going to draw 4 lines to create those 5 equal pieces, and I need to just do that. It doesn't even tell me to label them. So there I go. I've done my work, and I could label them if I wanted to, but for the sake of time, we shall move on. I'm assuming that the next page might show us. Yep, so I'm just going to scroll down here. I'm going to bring my number line with me. It says, how many 1/5 yard pieces does she cut all together? Use number bonds with copies of wholes to help you explain. So I'm looking at the number line that we drew on the page before. You could just turn back. And I can see that she cut 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, she cut 10/5, right? 10/5. So she cut that many pieces all together. And I could, draw a number bond and 2 holes, and I could draw all of those 1/5 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 10. And coming off of my would be a 1/5. I'm not gonna do that for the sake of time, but you could also draw your number bonds. You could also draw 2 number bonds for each hole. And off of each hole would be, say it with me now, 5 1/5 pieces. That's not meant to be an 11. I just thought that got cut off. Nonetheless, let us move on to lesson 27. Number 1 says solve. 2/3 is equal to how many twelfths? So in this lesson, we're talking about equivalent fractions. So how can we get from thirds to twelfths? Well, we can think about what times 3 equals 12, and I know that that would be 4. And so I'm going to also multiply 2 times 4, and 2 times 4 is 8, and so 8 twelfths would be my answer. 2/3 is equal to 8 twelfths. It says draw and label 2 models that show fractions equivalent in those problem 1. So I can definitely do that. I'm going to draw 2 equally sized objects or holes. So these are equivalent holes. They each represent 1 hole. In my first hole, I'm going to split into thirds. In my second one, I'm going to split into 12ths. So 1, 2, 8, 9, 10, 11. So now I have 12 pieces. And if I were to shade 2/3, and then I were to shade 1, 2, 3, 4, 5, 6, 7, 8, 12, I would say that they are the same. And that would mean that they are equivalent. And now I can move on and flip to the next page. Use words to explain why the 2 fractions in problem 1 are equal. So as I explained as we were doing it, as I was explaining my thinking, now I would just write those words here in this space. So I would say 2/3 is equivalent to 8 twelfths because when multiplied by the factor of 4, they represent the same amount of a part of a whole. And that would be that.